wanted to ask you also about your work in terms of process consultant and kind of product consultancy and so on, because I know you've done some work in this area as well.
Sure. So yeah, I mean, more recently, I've spent most of my time working with companies that are building a product. I end up with various titles. Sometimes I'm a pure consultant giving advice. Sometimes they bring me in as kind of an acting software development director, and my goal is basically to help them get up and running and build a software development team that is working effectively, implementing good development practices with high levels of discipline. Very often, they have a team, but the team isn't doing things like TDD or even just unit testing or component testing. And so part of my job is to introduce those concepts and get people thinking about how can I write an executable specification for this functionality so that we know when we're done that it actually works, as opposed to having to do manual testing of it. Putting in place modern version control practices, automated builds, DevOps kind of stuff. So, I spend a fair bit of time doing that kind of consulting. I also teach courses on developer testing. So my approach to developer test training is I teach how do you write good tests, and then as an afterthought, and here's how you apply it in TDD, as opposed to teaching TDD and teaching the how to structure the test properly as an afterthought. So I focus on a process agnostic way of teaching tests, and I give them chunks of code that they can't see and say, here's some tests for this code. Make these tests better. Change these tests the following ways. Fill in these missing tests. This is testing functionality X, but functionality Y isn't being tested. We need tests for that. Figure out how to do it, right? So I give them very focused ways of writing tests. And one of the things that I've discovered in this is how low the bar is. Yeah. And I use the analogy of, have you heard the story about the introduction of hand washing?
Yes.
Before surgery?
Yes.
And how long did that take? Do you remember?
I don't remember, but I remember it was a long time. It was years.
It was decades.
Yeah.
It was like 50 years.
Yeah.
And even today, in the operating room, my dad was a surgeon, so I know firsthand. Before doctors go into the operating room, they have to do serious scrubbing, and there is a special role in the pre-surgery washing room, the scrub room. There's a role called a scrub nurse. And the scrub nurse stands there and watches the surgeons wash their hands and helps them do it properly, because it is so hard to get people to do it properly. So now we're talking hundreds of years, right? So if you think TDD as the equivalent of washing your hands before you cutting a patient, and where we are in the adoption curve, I mean, it was kind of invented in the 90s, right? Popularized in the 90s through the Extreme Programming book. So we are only 25, 30 years into this, right? So, and if you think about what percentage of software developers are doing TDD today, what would be your guess? 10%, 20%? Are we up to 50% yet?
I would think closer to 10%.
Yeah, that's my feeling. It's like, most people you talk to don't do TDD.
Yeah.
And, that in some ways that's so frustrating, because once you know how to do it, you realize how effective it is. And the fact that we're 30 years in and still only at 10% or whatever the number is. But then you look at at something as simple as washing your hands before operating on a patient, and that took 50 years for just to become accepted as a standard, as a professional standard. And then it's still taking hundreds of years after that to be done well.
Yeah.
Right. I remember when at one of the early Agile conferences, and I think Martin Fowler was on a panel about extreme programming, and there were naysayers and there were proponents, and he just finished writing the I think it was the Green Book with Kent Beck about planning extreme programming, and he was working for ThoughtWorks already at that point, and he gets up on stage and he does his introductory spiel, and he says, "Yeah," he says, "extreme programming is like teenage sex." How's that? Well, he says, everyone's talking about it. Very few are actually doing it. And those who are doing it, very few are doing it well.
Yeah.
And that's kind of still, I think, where we're at with TDD. And so I'm trying to chip away at that a little bit by focusing on how do you write good tests? I mean, basically, the kind of stuff I talk about in my book on XUnit test patterns, which is what does a good test look like? How can you take tests that aren't so good and refactor them to make them better? So that when you do start doing TDD, you have the basic skills of test writing, whether you learn them by doing test after, retrofitting tests and suffering through the pain of trying to test software that wasn't designed for testability, or whether you were kind of writing them, thinking about testability and then writing the tests, which is a little bit easier, or the easiest is writing the test first and then the software is built to conform to the testability requirements that the tests specify. But by improving the skills on that front, I'm getting people ready to be able to adopt TDD when their environment allows them to do. And the funny thing is, I get brought in by large companies to train developers, and the bosses who bring me in are typically saying things like, yeah, our software quality is really poor. We need to improve the quality. Our predictability of how long it's going to take to do something is very poor. We need to improve that. They are very on board with having developers do unit testing and doing automated unit testing. Not that many of them are on board with they need to do TDD. So doing automated testing is considered good, and TDD is still considered fringe, which is kind of interesting and ironic because it's so hard to do automated testing well if you're not doing TDD.
Yes.
And the productivity really comes from the TDD because it avoids needing to debug your code. Whereas if you're doing test after, if you're trying to retrofit unit tests onto code that you already have working, you've already paid the debugging price on the code. So you've lost a large part of the benefit. And the tests are harder to write because the code isn't designed for testability. So it doesn't have the affordances for the test to be able to put it into the right state or observe the right state or access the little chunks of logic you're trying to test. And so the tests cost more to produce after. And you're very reticent to change the product code to make it more testable because it already broke and it's already worked, so you don't want to break it by refactoring it for testability, and you don't have tests yet to protect you while you do that. So it's like it's a triple whammy to write tests after. But ironically, that's the entryway that most companies are prepared to teach people how to do that, but they're not prepared to sanction having them do TDD, and especially not pair programming, which is also a key practice because it's the way the knowledge gets transferred. And it's kind of funny, I was on a conference call with a client last night, and we were capturing some plans in a database called Airtable, which is a really interesting technology. It's basically a database you can refactor on the fly and add columns and stuff as you need them, and direct editing. And now I'm a touch typist. He's a finger, hunt and peck typist. So he was having me do the work, and I was sharing my screen. And as we're going and doing stuff, he's like pointing things out to me. So if you go to the top right corner, you can click on that and do this, or we need to rename this column here, etc. And I turned to him and I said, what we're doing here is pair programming. And you've just illustrated the value of pair programming, because you're improving my productivity and transferring knowledge to me as we're doing this task, because we're working on it together. And rather than reviewing it after the fact, you're doing a real-time review and pointing out issues and helping me get more productive and helping me avoid introducing bugs. And he was surprised, because he'd never thought of that as programming.
Yeah, yes, it is hard, I think, for many managers to understand TDD and pair programming, because it's in terms of typical management, it's not natural. Having two people doing the same job sounds like you are paying twice as much for creating the same thing.
As part of my introduction to TDD module in my training course, I have a picture of an aircraft cockpit with a dog sitting in the co-pilot seat. And I ask people, would you fly on this plane?
Yeah.
And so if you wouldn't fly on a plane that only has one pilot, why would you trust your life to software running all by itself with no pilot, because it's doing things autonomously, and it was written by a single person working by themselves?
Yes. Yeah. It's a different thing. So code is very akin to knowledge, in fact, and therefore it needs to be managed differently.
Well, it needs to be managed more strictly than people, because people at least can make decisions outside the confines of what they were told to do, whereas code just does what it was told to do. So it's the code is not code is not adaptive. People are.
Yeah.
So a person working in a situation that they weren't trained for can figure things out for themselves and have a reasonable chance of success. Code, not at all.
Yeah. So you mentioned building teams that are productive and that follow these disciplines and so on. Is there a secret sauce to these disciplines, to getting to these teams?
Is anytime you're looking for a silver bullet or a secret sauce, it's a fool's errand, as they say, right?
Mm-hmm.
It's not do this and you'll be successful, don't do it and you'll fail. Building productive teams is hard. It's a lot of work. It's a lot of little things. It's treating people well. It's expecting them and empowering them to use their brains, training, and the right on-the-job encouragement. And one of the things that I found interesting and difficult and very effective is when I'm working on a software product. I was a software director of development for feedexcel.com, which is a horse nutrition analysis service online. I was acting as the product owner as well as the manager. Business people giving me competing that they wanted built. And sometimes I just had to say, hang on, guys, we can't build this new feature yet. We have to do some cleanup in the code.
Mm-hmm.
Because the number of bugs that our users are encountering have gone up and are unacceptable levels. And we need to spend a month and just beat these bugs down and find out how we introduce these and put in place some regression tests. And we put in place all sorts of fitness tests to cover the life cycles of key things in the system so that we could have better confidence in the quality of the software. And that's a really hard decision to make. And in many cases, the person in that position doesn't even have the authority. So they have to very much use influence and convince the stakeholders that they need to back off and give the team time to implement these practices that result in better software. Because if you just keep the pressure up, it's not enough to say we should do unit testing, we should do TDD, we should do this. Oh, here's a week of training. Now go back to doing work the same old way because I'm going to keep shoving features at you so fast and hard that you won't have time to even remember what it was that you learned on that training last week. So, you know, for me, a key part of a manager's job is to protect the team from management.
Yeah, that makes a lot of sense. So this conversation has been very, very interesting, and we are getting close to an end. But before that, I'd like to ask you: do you feel that your book is valid today? So, should somebody who is a junior programmer who wants to learn about these things, should they look at the book? Should they still learn from it? Can they still learn a lot from it?
Yes, absolutely. I mean, remember I said the important thing to learn is concepts and patterns and ideas. And if you tie yourself too closely to a particular technology, it'll be out of date. You'll notice that there are no code samples in that book that are tightly coupled to any legacy products, you know, even 5-year-old legacies like AngularJS. And that was a deliberate choice. I used basic programming languages and very simple examples to illustrate the concepts partly because doing examples in these esoteric frameworks and technologies is more work, but they're also more difficult to understand, and it reduces the scope of applicability. And that makes the book valuable to fewer people. So there are more specific books with more specific examples around that were written after my book, but which are probably already out of date. Whereas my book, because it was written avoiding those things, is every much as applicable today as it ever was. I mean, some of my thinking has evolved a little bit since then. I've switched from using setup, execute, verify, teardown to given, when, then terminology on my tests. And I think that makes my tests read better. But that's a very small and subtle difference. The fundamental patterns of how you structure the tests and why you do it that way hasn't changed. And I'm still getting people complimenting me on the book today now, and it's been, what, 12, 13 years since it was published?
Yeah, and I concur. It is a very useful book, and I advise people to actually go into it not with the intention of reading it front to end, but rather studying it. So looking through it and then coming back to it again and again at
Yeah,
specific examples.
I tell people it's actually 3 books in one. And there's the introduction section, which you can read end to end. It's 100 and some pages. And that gives you a good idea of what are all the different kinds of things and how they fit together. And then there's the section which describes all the smells and the troubleshooting charts that you can read or skim to use as a sense of what are the kinds of things to watch for while you're writing tests, to know that you need to think about doing something, the indications or affordances that maybe you should make some changes to the code. And then there's all the large book of patterns, 500 or 600 pages of the actual detailed refactorings. And that part you don't read, you jump to one specifically from the descriptions of the either the overview or the smells to see how you do one of these particular refactorings once you've decided you need it. So you only need to read, a couple hundred pages. So that's a much more manageable read. And the nice thing about reading it online, my website is still there. That was a conscious decision. I discussed it with my publisher about whether we should take it down or not, because a lot of authors will take down their website once their book is published. But we decided to leave it up because, a lot of the text has changed because the copy editors went to town, and probably 50% of the prose is reworded at some point or other, right? But the online version is all heavily hyperlinked. So as you're reading and it mentions a pattern, you click on the pattern name, boom, it takes you to that particular test pattern. So it's much easier to navigate than flipping through a hard book. And as long as you have an internet connection, you can refer to it that way. People who prefer to read physical book in front of them, for style reading, the book is better. You can also get in PDF form, so you can read it on your device, on your commute, and that kind of stuff. Or if you're in Japan, people in Japan would buy the book, and then they would slice it into chunks and only take the chunks on the book on the train. I actually had a fella at one of the conferences approach me.
Yes.
Nice to meet you. Would you like to see how we read your book in Japan? Sure, I'd love to. And he goes and he shows me this photograph. So here's the book with an X-Acto knife next to it and a ruler. And then here's the book with the cover carefully removed. And here's the book sliced into about 6 sections of about 100 pages each.
That's interesting. Yeah, I haven't heard about that. So I have one last question regarding to advice to junior developers. But before that, is there anything else that you'd like to tell our audience?
No, I've probably talked long enough by now.
So one thing that I like to ask people that accept these conversations is think about somebody who is a junior developer, who is just starting development, who wants to do a good job. And what would be some advice that you can give to such a person?
Oh, that's such a general question. Find a good mentor. Find a senior developer who seems to know what they're doing, who works effectively, who has skills that you don't, and who may be lacking some skills that you have, and pair up with them. You'd be surprised at both what you can learn from them and what you can teach them. As a proxy in this conversation for old fart developers, over the hill developer, if you want to call us that, I'm going to be the first one to tell you that I'm not going to be able to type as fast as the young kids coming out of school. I'm not going to be able to exhibit deep knowledge about specific modern software frameworks as them, because they've been studying them for the last few years, and frankly, I don't need to learn them, and I don't particularly want to learn them, because I don't make my living through my fingertips anymore, right? I'm not paid to type. I'm paid to think and to share my knowledge. And as a young developer, you're surrounded by, you might think of them as dinosaurs, these people who've lived through, using card punches and stuff. But there's a lot of knowledge there that if you can get at it, they will make you so much more effective as a developer. And, don't think of it as leeching off them, because you do have some things that they can learn from you. Every time I sit down and pair program with somebody, I learn something. So I view it as, a two-way street. It's an exchange. I'm happy to help you without expecting anything in return. but I do find that I do learn stuff when I do this. So it isn't purely a one-way street. And a lot of us older people in the industry, we're at the point in our careers where we're looking for ways to give back to the community and helping young developers learn and understand what's really important versus just learning the latest, buzzword compliant, software development framework. What are the really important principles and discipline, etc., that are worth focusing on and are difficult to learn by yourself, but are much easier to learn by working with someone and transferring the knowledge by doing real work together.
Yeah. This is excellent advice, and I concur. I've learned a lot by pairing with people who have less experience than me, so it's always a good thing. Where can people find you?
I'm on the internet. You can find me on LinkedIn. You can send me emails. agilecoaching@gerardm.com. So my first name and last initial.com. Anything at gerardm.com will get to me. I have a number of domains: testautomationpatterns.com, xunitpatterns.com, etc. So send me an email, send me a LinkedIn request, etc. My Facebook is reserved for my extreme kayaking and skiing and mountain biking activities, but LinkedIn is my professional networking tool. And if you send me emails, especially if you send it to agilecoaching@gerardm.com, it will get filtered into a special box so that I don't miss it.
Well, thank you, Gerard. This has been an excellent conversation, and I wish you all the good things to happen even during this pandemic. I hope everything will be good and you can still do your extreme sports.
That's right, and the irony is that this pandemic has kicked society into the future.
Yeah.
I was doing regular video conferencing at Nortel in the 80s.
Oh.
Right.
Yes.
So we had special video conferencing rooms that were set up with, big screens in them, and you'd go 15 minutes early to get the technology sorted out, etc. And this is how we communicated between our labs in Ottawa, the Research Triangle in North Carolina, Plano, Texas, Mountain View, California, and other labs around the world. We used teleconferencing on a regular basis. It was expensive, clunky machinery, and you had to book it long in advance to get the rooms. But it was a great way to avoid travel. And now everyone else has learned that you can do this from your phone or your laptop and not have to fly across the world just to be able to have an effective meeting with people. So welcome to the future.
Well, thank you, Gerard. This has been an amazing conversation, and I hope to our audience, I hope you found it as interesting as I did. We have to give our dues to the algorithm, so if you enjoyed this, please subscribe to our channel, like this, share it to other people and throughout the channels that you have at your disposals. And for me, I'd like to thank you for watching and remind you until next time to think, design, and work smart.